Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is air conditioning testing and diagnosis. And if you're watching this around the time that it came out, spring in North America, it is almost air conditioning season is upon us. So always a good idea to familiarize ourselves with how the systems work and how, especially nowadays with the automatic AC systems, how everything's kind of interconnected. And if I have a sensor that goes bad, maybe it could affect other things or cause other symptoms that maybe the customer would say, "Oh, well, my air conditioning's not work," when in fact it's really just the temperature blend door is stuck to hot or something of that nature. So we have to take all of those things into consideration into account. We'll walk through kind of both sides of the HVAC system on the vehicle, both the components outside under the hood, and then also the components in the passenger compartment as well. So if we look at how this is a Ford Explorer, and we can see there's a whole lot of things going on, especially since this one has both front AC and rear AC. So we have the different hoses and the ductwork and the different motors and such that go in to this vehicle. And it can be complex, and it can be a complex nightmare sometimes in order to diagnose what the actual problem is. Hopefully we can sort it out rather quickly, but it's an awful complex system and a lot of different failure points as well. So let's walk through a few of these. First, starting in the exterior, I'd call it out in the engine bay. A little bit of it comes into the compartment, but most of it's out in the engine. So we have the compressor. That's where kind of it all starts, right? We got our clutch, we got our oil, and we got our refrigerant that we have to worry about there. We have our evaporator, which is in the passenger compartment, and that's the part that actually cools off interior, um, the interior air, right? Then we have the condenser on the other side. That's usually out by the radiator, and that is where we take the high temperature and condense it back down into the liquid. We have our receiver dryer, our expansion valve, and miscellaneous pressure switches and sensors out under the hood. So start with the compressor. The majority of them are belt driven on gasoline engines anyways. Some hybrids and some electric, actually any electric vehicles are going to be electric, driven by the battery. Most of those are going to also be high voltage, 300 volts or more, just because they're running off just whatever the high voltage battery is on the particular vehicle. So usually it's gonna run right off of that. So that way we don't have the loss of the having to spin the compressor with the belt. Now, a belt-driven compressor is going to use an electromagnetic clutch. The clutch can be tested with the scanner, or we can do a component test on that as well, since it is an electrical part. Can either be a fixed displacement or a variable displacement. On vehicles with variable displacement, they might not even have a clutch. They might not need a clutch because we can move the internals, so it's not even pumping it, right? So that'd be like having a clutch engaging and disengaging. It's basically just the pulley is going to be engaged the whole time. So on the compressor, you can see we have the different connections here. We got a charge port, intake and discharge valves inside. There's the actual cylinder head there. And then we have these pistons on a plate. As the plate spins around, It's going to push these pistons up and down, which is going to uh, take the low pressure vapor and compress it down to a high pressure vapor, which then goes out the back. So the pulley's over here with the clutch. And then we have this wobble plate, which is going to change as it rotates. It is going to pump that gas around and through and compress it and make it raises the temperature and also compresses. So it looks something like this. So it's going to push the pistons back and forth. As we can see, it goes back and forth, and we have this wobble plate here. It's going to wobble back and forth. We can see how it's kind of controlled by this little hinge right here. It's going to push on that plate, and then as it goes by, you can see how it wobbles there, and then it just compresses and pushes it along. All right, so that's the swash plate. Now, wobble plate is going to work similarly, except the plate itself is on an angle instead of having that kind of adjustable hinge there. So that'd be a wobble plate. So the other one's a swash plate. This one's a wobble plate. And then variable displacement compressors will have the wobble plate that is variable. It can move depending on where they want it to be. So you can see how we have the different angles here. So it's going to move back and forth based upon how much of a pump, how much of an angle they want it to be on. So that is, it is adjustable. It's going to be adjustable by how much gas they allow up in here. It's going to push on this. It's either going to push it forward, or if there's no pressure or very little pressure, it's going to come back like this. You see, it's got a little bit of a spring on it. So with the control valve open and allowing some of the high pressure gas to push in, it's going to push that plate forward. It's going to make it less of a wobble. And then when it goes all the way back, it's going to be more of a wobble. And then an electric compressor, of course, it gets rid of the clutch, and then we just have a DC motor to drive it. Refrigerant goes through, and then it goes through this scroll type compressor, and then it just comes out the back end. So in this case, it's less complex because we don't have the clutch there to worry about engaging and disengaging. That brings us to refrigerant types. So there's really three main types and one little outlier there, and really you're not going to see R12 too much anymore. It was pre-1994 vehicles, then 94 to 01 or so we had 134A, and now pretty much anything 22 and newer is going to be 1234YF, but that started phasing in 2012. Also, there's R744, which is in some Mercedes E and S class, and I believe majority of them are in Europe, if not all of them. And also the European market, Audi A8 uses that. They're trying to avoid using the 1234YF because it is considered flammable. So R744 is not flammable, but it just never really kind of caught on in the automotive industry. So really, pretty much any vehicle nowadays is going to be 1234YF until they come out with something better. Also note with the compressors, with the oils, with your different refrigerants, there are different specifications and different machinery and equipment you might even need to use. So the tried and true since, like we said, 95 has been R134A, but they've been phasing that out. You also have R134A electrical compressors on like the Prius. That switched in 2010. So now still R134A. But there's a different oil. You see, we use PAG oil in this, and then we use ND oil over here because we need the oil to be non-conductive. All right. So there's a special oil that they use in hybrids just so because it has the electric pump. And so it doesn't, it's non-conductive. Also, they've been, as we said, we've been converting in started in 2013. Half of the 2017 models had it equipped, and like I said, now pretty much anything out there has the 1234YF. And then there is also 1234YF electrically driven compressors, which need a certain type of non-conductive oil as well. So we want to make sure between refrigerants, there's no contamination between refrigerants. We want to make sure there's no oil contamination between those types as well. And then even the 1234 versus the 134 may have a different oil as well. So a lot to keep track of. And how do I know what the vehicle uses? The best place to look is going to be underneath the under the hood there with the air conditioning system label that's on there. It's going to tell you how much, which is critical nowadays, by the way. There are these things called critical charge vehicles. They don't have a necessarily a large amount of refrigerant in there, and there's not a lot of leeway between overcharged and undercharged on a lot of these newer systems. They call them critical charge systems. So with that in mind, you do need some specific equipment depending on what you're working on. These are just 4 examples that we make. So we have a hybrid compressor, which is explicitly for hybrid vehicles, like I said, special oil, also for critical charge. We have one that's dual that does 134 and 1234 YF, but not hybrid. And then we have a 134 only, and then we have a 1234 YF only. So it just kind of depends on what you need in the shop. As far as weights for the critical charge systems, we do have the most accurate scales in the industry. So that's something to keep into consideration as well, because if you overcharge or undercharge a vehicle, it can cause problems down the road as well. Here's just an example of why we need to pay attention. So we have a 2016 Ford Focus with a 2-liter, and it says that takes PAG oil and R134A, 1.3 pounds of R134A, versus the 2017, which is going to look identical on the outside because that was the last generation in North America. But in this case, it takes 1.37 pounds of R134. And it is PAG oil, but it's a different specification for the PAG oil as well. It takes a little bit less oil, a little bit more refrigerant in there. And notice the difference, though, 1.3 pounds versus 1.37 pounds. That's where it comes into that critical charge. We need to make sure we're charging it exactly what it's supposed to have. And once again, how do I know? Just check the label. And if you don't have the label, then you need to go into your repair information and look up the proper year, make, model. That way would be, I guess, the second best, because I would err on the side of the label, just because sometimes things can change mid-year that don't always get picked up. So I would always refer to the label first, and then my repair information. All right, so that's the start of it. That is my compressor and the refrigerant, which is the main star of the show here. Now let's move to other items here. So we have the evaporator. That is going to be in the passenger compartment. Warm interior air is going to blow over the fins. As the heat is removed, the liquid is going to turn into a vapor, because it is going to heat up that liquid and it turns into a vapor. Usually it's going to be in the heater box near the heater core, maybe right next to the heater core. Just kind of depends. But as it goes in, you're going to have a low pressure liquid go in, and then a low pressure vapor comes out and goes to the compressor. The condenser comes out. It's in the engine compartment, and as the ambient air and fan cools that refrigerant that was high temperature coming out of the compressor, it's going to condense into a liquid, and then it goes out and back around. The receiver dryer is going to filter the refrigerant, and also contains a desiccant, which is going to help remove any water that's in the system. Hopefully there isn't any water in the system, but there may be. This should be changed out anytime the system is open, because as soon as I crack it open, it's going to introduce any of the ambient water vapor that's in the air into the system. So I need to make sure that that gets replaced, because that'll mess up the desiccant. Also on expansion valves on most 134A and 1234YF, it's going to step down the pressure before it enters the evaporator. All right, so high pressure liquid's going to come in from the receiver dryer, and then based on this metering ball and this diaphragm up here, it is going to send it out to the evaporator inlet as a low pressure liquid. So it goes from high pressure, steps it down to low pressure. And then the outlet pressure regulates the inlet pressure. So the pressure coming out of here is going to affect this diaphragm. It's going to move this needle valve up and down. Whatever the pressure coming out here is going to dictate whatever the pressure is coming in. And this can be a common failure point. I know on Subarus for sure that is a very common failure point, because you can just see the oil coming out, leaking. The O-rings in here can leak pretty commonly. So that can be a good failure point, also a good test point on there. Then we also have pressure switches. So it's going to power on or off depending on the pressure that's in there. Can be separate high and low and medium. Can also be a combination switch with high and low in there. So depending on voltage, this one's kind of an on-off, so power goes in. And then depending on the pressure, if there's enough pressure in there, it'll press, the contact will close, and then it'll turn the clutch on, turns the clutch off. So those are just kind of dumb switches. Based on pressure, it's going to kind of turn it on and off like a reed switch. And then also you could have pressure sensors, which are actual pressure sensors, and sends the signal back to the control module that measures in PSI. Right, a voltage that changes into converts to a PSI. All right, HVAC electronics on the interior now. So that's all the exterior in the under the hood, kind of up to the firewall area. Now let's talk about the interior. So the interior is going to be maybe miscellaneous sensors like inside and outside temperature sensors, sun load sensors that can be actual output sensors at each of the vents. They can have sensors there as well, depending on how complex the vehicle is. We, of course, have our blower motor in there, or motors if we have front and rear. Also, the motor would have a controller in there. Actuators as well. So mode door, blend door, and recirculation actuators are going to move those automatic air conditioning actuators and different things. So if we look back at this Explorer that we looked at the beginning, you see we got the front and the rear, and also everything that's out under the hood. And if we look at this schematic, there's different sensors. So we have the HVAC control module, and that is going to have miscellaneous sensors. So we have transducers, sensors, different things like that. Sun load sensor, in-vehicle temperature and humidity sensor, evaporator sensor goes in the HVAC control module. We also have the inlet door, all the different actuators here as well. And then we have the blower motor speed control, blower motor relay, AC clutch relay, and the clutch coil itself. And there's also an externally controlled variable displacement compressor. So all of that stuff gets operated between the PCM and the HVAC control module. So if we have a failure point somewhere, like for example, the temperature door was swung all the way to hot and it won't go over to cold, customer may say, well, my AC is blowing hot. Now, is it a problem with the AC itself, or is it actually with the actuator? So there's where we need to figure out where the actual problem. So let's talk about the sensors. We have the sun load sensor, which is a photodiode, and what that does is it converts solar radiation to a voltage output, and it's read as a PID into one of the modules. The control module uses that as an input. So it knows how much sun is beating down on the dashboard and getting through the windshield and all that, so that way it can help dictate how quickly and how it sets up to cool off the interior. Ambient air temperature sensor is going to be on the outside of the vehicle. Usually it's behind the bumper. And usually it's shielded from any air, so you don't get any cooling effect from the air going by. It is a thermistor. Converts ambient air temperature once again to a voltage. The control module will use that as an input to see, well, how cold is it outside today? Or how warm is it outside? Then with most automatic air conditioning systems, you're certainly going to have a cabin air temp sensor. So it's measuring what the ambient air temperature is inside the cabin. It is also a thermistor, converts in-car air temp to a voltage. The control module uses it as an input, and usually it's in the center dash area. It wants to be fairly close to where the driver is, because the driver is definitely going to be the person that's inside the vehicle the most. Could have passengers as well, but we want to make sure that the driver is comfortable. And there it is right there. This is susceptible to damage if you're not careful. Also susceptible to getting dirty, just like a mass airflow sensor would. So we always want to watch out for that. Then, as I said before, there can be multiple air duct temperature sensors in the vehicle as well. Those are also thermistors. Converts the air duct temperature to a voltage, which the control module then uses as an input. And usually, like I said, it's in the air duct itself. Maybe not quite at the very end, but maybe at least a few inches from the end, from the output side of the air duct. And as you can see, it just kind of clips in there as a little barb fitting there. A foam piece. Also, windshield temperature and humidity sensor. That's combined temperature and humidity in one. It's going to measure the windshield temperature, the cabin humidity, and the humidity sensor temperature itself. It's good. Control module is going to use that as an input, and it's going to be mounted to the upper windshield usually, and that will help everything make that calculation as to how hard do I need to operate this air conditioning system to get the temperature down. And now let's talk about actuators. Those certainly can be a failure point underneath the dash there. So it is a reversible electric motor. Usually it's going to use plastic gear reduction, which is where one of our failure points can be. Oftentimes it also contains a position sensor inside. So the whatever's actuating it, the ECM, the HVAC controller, knows where it is in space. It's going to operate linkages for the recirc door, blend door or doors, and mode door or doors, depending on how many zones of climate I have. So here's a heater box, and we can see mode door actuator is going to be there. So that's going to be, say, my defrost, my floor, my face vents. And then my air mix door actuator is going to be, my hot to cold, side to side. So we have a bunch of, this is just it's one of my drawings of a basic heater system. And we have the different vents and the different mode doors in there with the different actuators that'll happen. So in this case, we're recirculating. You see we have outside air here with the cabin filter coming from outside, and that door is blocked. So it is sucking in air from the cabin through the blower motor, through the evaporator, and so on and so forth. Now, if we wanted to go from recirculation to outside air, it would just simply move that over, and then it comes out through here, through the blower. Also the blend door. So in this case, we're on recirc, and it's going over the evaporator only. It's not going over the heater core, so it's just going to blow cold air. And in this case, it's going to the floor vent. If I wanted to go full heat, it's going to go over the evaporator still, but then it'll go over the heater core, and the heater core will heat it up. In this case, we're going through the floor vent. We want to do a 50-50. It's going to take my cool air and my warm air, and it's going to blend it in a way. And then we have medium air going out through, in this case, the floor vent. All right, let's talk airflow on the different mode doors. So in this case, we're going just to the floor vent because we have these two other doors here. If we wanted to go to just defrost, we can do that. It's going to go up like that. And then if we wanted to go 50-50, defrost to dash, or if we wanted to go full dash, we could also go dash floor, defrost, what have you, any combination depending on where those mode doors are. If they're halfway, we're going to split the vent between. Now, in a vehicle with dual zone climate control, it's going to have these doors here. It's going to also have my recirc door there, and then it's going to depend on where it goes, redirected out that way. So if it opens up here, one side can open and close. The other side can open and close as well. And that's going to be my different speeds. And then my temperature doors can swing back and forth depending on how warm or how cool I want it on either side. So it's going to split the air. So this would be the driver's side, and this would be the passenger side using the same blower motor, and then it'll just regulate the temperature based on the temperature. Now, as far as these actuators, they can have problems. So in this case, we have a bad blend door actuator. So it's not allowing the heat to go to the passenger side. It's only on the driver's side there. We can kind of see in the middle. And then after the repair, we can go and take a look with the thermal, and we can see that's hot on that side, hot on that side. The door is actually working. Also, after I'm done repairing an actuator, I may need to do a recalibration. So in this example, it's on a 2017 GMC. Using a scan tool, perform the HVAC actuator learn in the HVAC control module. So you'd actually go in. It's a functional test that you do. It cycles the actuators back and forth from the full range of travel. And it will either throw a code if there is a problem, or it'll give you a pass. If the unlearned actuator is not physically rotating, replace the actuator. Otherwise, replace the HVAC controller. So we can see which ones do work and do not work. And oftentimes when they do not work, it's because of something like this. So maybe it got stuck at one point, and then it ended up stripping on this gear right here. So we can see that's where that would be flipped over. And then we would have the gear right there as to where that would be. And then it may strip it, and then I would have to either replace the gear, repair the gear, or most times you're probably just going to replace the actuator. See how I have a worm gear here and a reduction gear. All right. So that is my slides. Let's go on to the scan tool and take a look at a few things there. All right, so here's our first vehicle here. We got a 2017 Ford Focus. So let's see what we can do inside the scanner. A few different functions we can do. So we have engine, which is going to deal with some of the compressor stuff. So if we go in there under like functional tests, output controls, you're going to have your compressor cycling switch. That's pretty much all you're going to have in there as far as engine stuff. You may have data though. Go into data, and sometimes it's on, like in this example, AC data. Other times it might just be on your generalized engine management data, but in this case we have AC data. Go through there. And you can see clutch output, AC pressure, AC request signal, pressure sensor voltage, compressor command. So some of this stuff can be useful just from sitting in the driver's seat. You can see different pressures and whatnot and make sure everything's working the way it should. You can command the compressor and see whether or not it actually sends out the compressor output. Um, let's also go down to HVAC. So under HVAC section, we have HVAC, heating, ventilating, and air conditioning. And you can see codes, data, functional tests. As far as the functional tests, you're going to have a few different output controls like air mode actuator, blower motor speed, left blend door positions, etc. There's also data display. So this is going to be more of the interior of the vehicle. So things like the fan, the actuator percentages, whether it's set to auto defrost, what is the air temperature? Because this one has the temperature sensors we were talking about in the different ductwork. It, right floor, how many degrees, external temperature, solar radiation sensor, right? So it's got a lot of those sensors on the interior of the vehicle that we talked about as well. In-car temperature, evaporator temperature. So you can get a lot of data just from here. And this is where the computers are going to make their decision based on, of course, this data, whether it's right or whether it's not. So sometimes you just need to verify that if everything else checks out, okay, maybe it's a different sensor. Now, to that point, inside Guided Component Test, if you do have one of our tools with the Guided Component Test module in it, we do have a section for HVAC. Right, so we go into HVAC. In this case, on this focus, we got the clutch relay, compressor clutch, and then blower motor relay. So if I wanted to look at the compressor clutch, the component information here. AC compressor clutch is a 12-volt electromagnet. When energized, it engages compressor clutch to drive the belt pulley. This turns compressor for AC operation. And then we have the clutch relay, and then wherever the grounds are, depending on what it has for an engine in there, it's going to be in a different spot. At least it tells us that. And the best place to test it is going to be at the clutch itself. And then looks like we can do a DC voltage test, which is going to make sure we have power supply and ground. Cycle AC system controls the max cold defrost to command the AC clutch relay on. You could also do a functional test in order to turn that on and off. And then resistance test, it's going to say, either side of the coil. So just plug it across, disconnect it and plug it across. Should be less than 3 to 5 ohms if out of range, suspect a faulty clutch coil. So that's fairly common. We'll have an internal failure of the clutch, and that'll actually cause your AC not to work or not to blow as well. And then in the engine, we have things like the pressure sensor, ambient air temperature sensor. Those are in. Sometimes they're under engine, sometimes they're under HVAC. Sometimes you just have to look for them. So in that case, AC pressure sensor, ambient air temperature sensor. Now it's just going to really tell you where it is. And then AC pressure sensor is we have a couple of different tests we can do as that as well. AC pressure transducers used to monitor the compressor discharge pressure and sends a variable voltage signal representing the pressure of the PCM. Not necessary to recover the refrigerant before removing the AC pressure transducer. So that's good to know too. So I don't have to drain the system down if I just have to replace that pressure sensor. That's pretty good to know. All right, so that's focus. Let's look at something else. Let's look at how about a RAV4? Pretty common vehicle. So once again, we have 2 different sections. So I'll go to HVAC first. I see codes, data, and actuator test, system test. So data display is going to give us, this is all going to be like the interior stuff, right? So evaporator, thermistor, ambient temp sensor. This is all the inside the vehicle stuff, adjusted ambient temperature, etc. As far as actuator tests, the fogger relays, magnetic clutch relay, which would be my air conditioner clutch, inlet damp, air out pulse. And then system tests are going to be servo motor initialization. Remember how I said if we replace one of the actuators, we may have to do that initialization. So you just go through there. It's going to need to be done if servo motor ECU is replaced, AC amplifier is replaced, batteries disconnected, or the AC is not working normally. And then it just gives you a few conditions. I know it's going to give me an error out because I'm not hooked up to a vehicle. Also on this one, I thought was kind of interesting is we have a customized setting in here. So inside the HVAC system, you can change all of these different things. Turn them on, turn it off. For example, let's see, outside air mode auto switch function. So this function switches on or off of the function of the switch to suction opening the outside air mode automatically at the time of the ignition off. So it'll either leave it sealed up or it'll open it up automatically when I turn it off. Footer defrost auto mode, evaporator control, all sorts of different things we can do in there and turn them on and off. You could be useful for diagnostic purposes. Also, could be useful for like a customer service type thing. Maybe. My windows are fogging up overnight. Okay, well maybe we want to let that outside air get in so it can equalize the humidity inside the outside. And then as far as got a component test on this one, it's got a fair amount. HVAC system again. So AC pressure sensor, ambient temperature sensor, sun sensor, blower motor, cabin air temperature sensor, evaporator temperature sensor, mode switch. All of those things can be tested using the guided component test. Figured we'd also check on a hybrid. So we'll pull up a Prius. And in this case, this does have an engine because it is a hybrid, right? So you can go into engine, and that's going to have maybe one or two actuator tests in there. There's a whole lot of different tests, mostly not to do with the air conditioning in there. But you're going to have the magnetic clutch in there. Data display, you might have some temperatures and pressures. But down here again, in the HVAC, data display, that's going to be your ambient temperatures, evaporator temperatures, electric heater levels, compressor target speeds, shift set temperatures, blower motor speed levels, etc. So a lot of the interior stuff again with that. And then as far as component tests, we do have an HVAC system here as well. Humidity sensors, ambient air temperature, blower motors, sun sensor, AC compressor, refresh recirc door, rear window defogger, etc. So a lot of stuff in there. And then lastly, let's go into a beamer and see, because that BMWs are always kind of interesting. So they're over engineered. So sometimes you have some interesting stuff that you can do. So let's see, for example, air conditioning there. Codes and data. Let's say AC compressor. It's going to give you a couple things on there. They have really small data banks, I've noticed too. But under functional tests, there are some special functions like in installation position of the flat motors. For that's once again reconfiguring the blend doors. This one was interesting too. Run-in protection for AC compressor. So if you replace the compressor, in order to protect it on initial startup, it's going to do this. When renewing the air conditioning compressor, the run-in protection needs to be switched on prior to initial operation of the air conditioning compressor. When switching on the run-in protection of the air conditioning compressor, the proper distribution of the refrigerant oil in the refrigerant circuit, as well as protection from mechanical damage in the running in phase of the air conditioning compressor, is ensured. So you would go through and continue through this and follow on. It takes about 10 seconds to switch on, and you would just tell it to switch on. I think it's going to fail because I'm not hooked to a car, but we'll see. So give me 10 seconds. All right, so it couldn't be activated because, like I said, it's going to give me an error in this case. But it would say whether or not it was successful, and then you would run it for a couple minutes, and then it would make sure that it has oil and that it's not going to get damaged with that. So one or more things got a component test, of course. And this is a 5 series, so that is let's go with a 530i. That's what it should be. Okay, and then in this case, engine actually doesn't have anything. Charge air pressure. No, that's for the. So yeah, not really anything available for the BMW in this case, but a lot of other engine-related stuff in that case as well. All right, so that is air conditioning. Hopefully, we've realigned our thought process maybe a little bit. So when the customer comes in and says, "Hey, my air conditioner's not working," well, what part isn't working? Is it low on refrigerant? Do I have something wrong with the compressor? Do I have a clog? Do I have a leak? Or is it something internally entirely? Could it be like one of my blend doors is stuck? That could be. Could be my sun load sensor screwed up, or my ambient air temperature screwed up. So there's all these different things that we need to concern ourselves with now, more than just are we putting the right amount of refrigerant in, which is another thing we need to be concerned about because of that critical charge issues. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully, you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.